All right, so let's go ahead and get started on the Chapter 2 review here. So looking at the learning targets for this section, we are looking at simplifying an expression by combining like terms, comparing two complicated algebraic expressions, and then we see down here 15 through 18, understanding that equation can have a solution, no solution, or all solutions, and solving for unknown variables. All right, so let's hop right into it. First off, I'm going to start by writing my name. And then I'm going to move into the problems. The first part is I can describe a proportional relationship as seen in a table and a graph versus a non-proportional relationship. So it's asking proportional or non-proportional. And so I remember with proportional relationships, it needs to have two parts to it. If it's a graph, it has to have a linear line or a straight line. And that's going to be our constant rate of change, meaning that our x goes up by the same and our y goes up by a steady amount as well. And then the second part of it is going to be, does the line pass through the origin? Remember, that's going to be passing through the point 0, 0. All right, so if we take a look at our first table here, we're going from 1 to 2, 2 to 3, 3 to 4. So we're going up by 1 each time for our x. And then I'm checking for my y if we're doing the same thing. So from 4 to 8, we're going up by 4. From 8 to 16, we're going up by 8. And from 16 to 32, we're going up by 16. So notice we're not going up by the same number each time. We don't have our constant rate of change. So we don't even need to graph this because we know that the line is not going to be straight. Therefore, we can say that that table is not proportional. Looking at part B now, do the same thing. Right now we're going up by 2 for our x each time. And then for our y, we're going up by 4 each time. There is our constant rate of change. And so it has met that first requirement of, is it linear? But now we have to look at, would this pass through the origin if we were to graph it? So let's go ahead and do that. I'm going to have my x and my y-axis. And my x goes up to 7, so I'm going to make 7 marks. And then my y goes up to 14, so I'm again going to make 7 marks, but this time I'm going to go up by 2 each time. So here we're going up 2, 4, 6, 8, 10, 12, 14 on our y. We're going to go up 1, 2, 3, 4, 5, 6, 7 on our x. Now we can start to plot our points. Our first one is 1, 2, or 1 for our x, 2 for our y. So that's going to be right here. Then we have 3, 6 as our next ordered pair. And then we have 5, 10. So that's going to be right here. And then finally 7, 14. So that's going to be right here. Not a perfect graph, but we do see if we connect these lines, it is indeed a straight line. And better yet, it passes right through our origin, 0, 0. So therefore, since it passes through the origin 0, 0, we can say that it is proportional. And you could tell that by just looking at the table. If you were to subtract 2 instead of add 2, you would be at -1. And if you subtracted 4 for our y instead of adding 4, you'd be at -2, which means between 1 and -1, you would pass through 0. And from -2 to 2, you would also pass through 0. All right, not proportional and proportional. And now we're moving to C and D. So our first one, we're looking at, is this line straight or linear? Well, yes, it is. So straight line, check. Now we're looking at, does it pass through the origin, right? Point 0, 0. And here we see it does, right? This is 0 for our x, 0 for our y. So therefore, it is proportional because it meets both of the requirements for a proportional graph. And now we have to look at part D. Starting off, is this a straight line? Is it linear? Yes. Does it pass through the origin? Here we start at 0 for our x, right? But it's up here starting at 1 for our y. So it doesn't pass through 0, 0. doesn't go through the origin, therefore it is not proportional. And on the test, we do expect you to show all of your work just like I did here, because we can't read your minds when you're taking the test. So please show your work, go through the checklist just like I'm doing, and then you'll get full credit. All right, now we're looking at learning target 4. I can solve a proportional relationship by setting up a proportion for an unknown part of one ratio. Now, this may sound a little complicated, but all we're doing is setting up a proportion, meaning a ratio proportional to another ratio. And here, unknown part, we can represent that with x or y or whatever variable we choose. And so here, I need to make sure that my parts are in order. And what that means is if Carsey was trying to figure out how much Havarti cheese she would buy for $10, knowing that 3 pounds costs $7.50, we can say, okay, we know the part here is $3 or 3 pounds for $7.50. So I'm going to go ahead and put my pounds on the bottom, and I'm going to put my cost on top of $7.50. And so when I write a proportion or a ratio that is proportionate to it, I have to make sure that I'm going to do the dollars on top. All right, so the top is going to be my money, and the bottom is going to be my pounds. All right, I have to stay consistent here. So here on top, I have $10, right? We know that from the other part of our problem. And then we're trying to find how many pounds that would be. So I could say X number of pounds. So what I can do here to solve for X is simply cross multiply. All right, so let's go ahead and do that. I'm going to do 3 multiplied by 10. It's my first part. And that's going to give me 30. And then I'm going to multiply 750 by X. Now, if we do 750 times X, that's going to give us 750x. And so remember, with algebra, the key is to find that unknown value, that variable that we're trying to figure out. So here I'm going to try to get x by itself by dividing 750x by 750, right? The opposite of multiplying by 750 would be dividing by 750. So we do that to both sides. And so here I'm going to grab my calculator. Actually, I don't need that because we can do 7 goes into 30, that's 28, and then we still have 50 goes into $2 4 times, so that's going to be 4 equals x, right? 7 times 4 equals 28. 4 times 50 is going to give us $2. 2 plus 28 gives us 30, so 4 equals x, and we can say with confidence that that would be for 4 pounds. $10 would be for 4 pounds. All right, now we're looking at part B. Same deal here. I'm going to cross multiply, and I'm going to cross multiply. So that leaves me with 36 for 4 times 9, and that's going to equal 10 times x, which is just going to be 10x. And so from here, I want to get x by itself, and so I'm going to divide by 10, and then divide by 10. And so here I'm going to have x by itself, right? Got rid of the 10 here. And then 36 divided by 10. Well, we can just move that decimal place over one spot. So boom, we move it over here. And now we're at 3.6. So 3.6 over 4 is equivalent or proportional to 9 over 10. Right? That is in proportion to 9 over 10. All right. Circled my answer. I'm all good. This isn't my final answer here for problem B. I want to make that clear, right? 4 is my answer for problem A. Moving on to learning target 5. I can find the unit rate for a proportional relationship. All right. So proportional relationship again, which means I am going to have a ratio compared to a ratio. This time it is a unit rate. So I know I need to have my ratio over what? Over 1, right? It's going to be over 1 or per 1, right? Miles per hour, points per game, cost per pound. So here, if we're doing 360 miles, I'm going to put that on top because I want my 1 to be on the bottom, which means it's going to be 6 hours. I can make that into 1. Also, generally speaking, hours, that's going to be our x value, and we typically write it as y over x. Therefore, 360 is our y, and 6 hours is our x. And then we're going to set this equal to something over 1 because we want our unit rate to be over 1. So what do we have to do to get from 6 hours to 1 hour? We have to divide by 6, right? And so we know up top here, we also are going to divide by 6, right, to keep it proportional. So 360 divided by 6 is going to give me 60, and boom, we're doing 60 miles per hour. All right, pretty standard. You could also multiply across just like we did up top. So if we cross multiplied here, then we get 360 equals, well, before we found that 60 miles per hour value, we could have represented it with x. And so we could have cross multiply here, and we're getting 6x. And so trying to get x by itself, so the opposite of dividing or multiplying by 6 would be dividing by 6. So we divide the other side by 6, and there we get 60 equals x. All right, so you can cross multiply and find that missing value x. You can also do like I did below, where you're like, oh, I need to get from 6 to 1 by dividing by 6, so I do the same thing up top. We'll do problem B with our proportion cross multiplying. So key here is how do we set it up? All right, so the deal is 6 donuts for $5.34 or 9 donuts for $7.20. All right, well, this time around, I'm trying to find my unit rate. So my proportion is going to be my money on top. That's going to be my y, or my dependent variable, over my x, which is going to be donuts. And here, I want to find the cost per donuts, right? Per donuts. And so we're going to have 1 donut on the bottom for this ratio. And so here, I can cross multiply. And then I'm going to get 534. And then here I have 6 multiplied by x, my missing value. 6 multiplied by x is going to give me 6x. And so from here, I can divide both by 6. And let's see, if I do 534 divided by 6, I'm going to grab my calculator for this one. That is 89 cents. All right, so divide by 6, and we have 0.89 equals x, which tells me 89 cents. Cent sign goes after. And then over here, we have 9 donuts for $7.20. So I'm going to do the same thing, set up my proportion, dollar amount on the top, number of donuts on the bottom, set it equal to, I want my 1 donut on the bottom because I want cost per 1 donut, and then my missing value x on top. Really, this would be y. That might be a better variable to use. And so here we're going to cross multiply. So we have 720 equals, and then 9 times x is going to give us 9x. Here we're going to divide both sides by 9 to get x by itself. So here we have 80 cents for x, the cost per donut. And so what's the better buy here? Right? I want the better deal. Well, is it going to be the one that costs more, or is it going to be the one that costs less? It's going to be the one that costs less, right? So 1 donut for 80 cents is definitely the way to go. So I would say 9 donuts for $7.20 is the cheaper option. All right, now we're going to move on to problem for learning target 6. So here we're looking at our diamond problems. And we know up here we have our product, what they multiply to make, and then our sum, what they add together to make. So we're dealing with 3 and negative 7. If we're going to add those two together, 3 plus negative 7, that's going to give us negative 4. And then if we multiply them together, 3 times negative 7, I really should not use that x because that could represent a variable. So 3 times negative 7, that's going to be negative 21. Now moving on to the next one, it says 2 multiplied by what is going to give me negative 10. Well, I know it needs to be a negative number, and 2 times 5 gives me 10, so negative 5. And if I add 2 plus negative 5, or 2 minus 5, it's going to be negative 3. And then over here for C, all right, let's see, the factors of 24. I know 6 and 4 is a factor. Would that work? Oh yeah, 6 and 4 can add together to make 10. But here, they need to make negative 10. And so I know that they're going to both be negative. And we know when we multiply two negative numbers together, we're going to get a positive number, in this case, positive 24. All right. Moving on to the next problem. I can plot points and name coordinates of a point on a graph. So here I'm just looking simply at where these points are on the graph in correlation or in relation to my x-axis and my y-axis. All right. So here I'm looking at point A to start. That's going to be 1 over, all right, so minus 1 on my x-axis, and then it's also 1 down on my y-axis. That's where point A is. So that's going to be at negative 1 for my x and negative 1 for my y. And then we're looking at point B. Well, that is negative 1 on the x, right? We're going 1 over backwards on our x, and then we're going up 2 for our y, up 2. So that's going to be positive 2. C, we're going over positive 4, and we're going up positive 2. D, we're going over positive 4, and we're going down 5. So it's going to be negative because we're going down. And then E, we're going to the left or in the negative direction 5 spots, so negative 5. And then we're going down 5 spots, so that'd also be negative 5. All right. I can recognize and extend patterns. Okay, here's where algebra really comes into play with these patterns, all right? Saves us a lot of time. So first off, I am looking at what I'm starting with in my first figure. And you're like, what do you mean by that? Well, I'm just going to simply count how many tiles I have to start here. All right, looking at figure 1. And I have 1, 2, 3, 4, 5, 6 tiles to start. So I'm just going to keep this 6 here when I'm creating my pattern. And I'm going to go ahead and just start off by highlighting those 6. And now what am I adding to each of my initial figure? All right, so to my initial 6, how many am I adding here? And we see by outlining the color in a different color of the part we added, we are adding 1, 2, 3, 4. All right, so it's going to be 6, that initial 6, plus 4. And I'm going to do the same thing on this next one here. All right, I am going to show my initial 6. All right, so 6 plus 4. This time it's going to be 6 plus something else. And this time it's going to be plus 8. Right? And so really we're just adding 4 each time. But now I'm trying to think of an algebraic equation that could help me so I don't have to just simply add 4 each time. Okay, well I know I'm starting with 6. So 6 is going to be my constant. All right, 6 right here. The 6, that's going to be my constant because I'm always going to have that initial 6. So let's see, if I'm starting my equation, it's going to be plus 6. And then right here, if it's figure 2, what could I multiply 2 by to show that I'm increasing by 4? Well, let's see.